Wait,
It's on YouTube.
it's on YouTube.
I highly doubt middle-aged people care about what.
One of my videos has like 3,000 views. So
Oh no, because I was in it, right?
just be aware.
Sure, Sam.
Oh no.
All right, 6.6, solve absolute value inequalities. So obviously we have done a lot of solving inequalities so far this chapter. Yesterday we started absolute value equations. And so we're going to be getting into, obviously, inequalities now. And so these are going to be a little bit different than what we were doing yesterday. They're still going to be like 2 problems, but in terms of how it's actually set up, it's going to look a little different. So we have some things that we need to know about them. Let's just do this. Can't spell. All right, so the inequality the absolute value of ax plus b is less than c, where c is greater than 0, is equivalent to the compound inequality negative c is less than ax plus b is less than c. I'm going to leave a line because I'm going to write something under that in just a minute. The inequality, the absolute value of ax plus b is greater than c, where c is greater than 0, is equivalent to the compound inequality ax plus b is less than negative c, or ax plus b is greater than c. So I said earlier, obviously we still technically have like 2 problems when we do absolute value, but if it is a less than sign, okay, it's an and problem. And so we have it where it's set up between like this, okay? So it's still like having 2 separate things. If you do them as 2 separate problems, your answer will just end up being smushed together based on what your final answers give you. So it's easier just to set it up like this to begin with. If it's an or problem, or if it's, let me back up. If it's a greater than problem, like this, then it's or. We copy one of them down exactly. Okay, so ax plus b is greater than c, just without the absolute value bars. On the other one, though, we make it negative c, and we flip the sign to be less than, because it's a similar reason to when we do, like when we multiply or divide by a negative, we flip the inequality. Essentially, that's what's happening. So since we're changing the sign of this, we're flipping the inequality on that one. Okay, so the one that is, there's one copy down exactly, then the other one, the sign changes, and the inequality flips. Okay, so what I'm going to write underneath here is that it's land and gore. Okay, so if it's less than, it's and. If it's greater than, it's or. Okay, and this also works if it's or equal to. So if it's less than or equal to, it's still and. If it's greater than or equal to, it's still or. Just using those ones as like the one for reference. But that little acronym hopefully will help you to remember which situation you're dealing with. If not, like I said, you can still get it from doing your final answer. You will just have to smush it together after the fact, which some people struggle with a little bit more. Some of them may want us to graph the solution, so we'll also be doing that on a few of them. Oh, one other thing, we would still need our absolute value to be on the side by itself. So if you remember yesterday when we had ones that like were being multiplied by something or had something like added or subtracted from them, we had to move that over first to start with. We still will have to do that in these problems. Like the absolute value has to be by itself for this process to occur. Okay? So let's jump into a few examples here. So these ones say to solve the inequality and graph your solution.
Graph?
Yeah, just on the number line.
Oh, okay.
We will be actually graphing inequalities with like two variables in them in the next section, but that's not what today is. Number 4. The absolute value of y is greater than or equal to 3. All right, so this is a greater than problem. So that means this is going to be GOR because it's greater than. So one of them gets copied down exactly as it is. So it's going to be y is greater than or equal to 3. Or the other one, we bring down what's inside. So y, we flip the inequality. So less than or equal to, and we change the sign, -3. Now, technically speaking, to be in numerical order, I should rewrite them. It's not wrong if you don't, but y is less than or equal to -3, or y is greater than or equal to 3. Then at this point, we're just graphing on the number line like we did the other day. So it seemed like when I graded y'all's quizzes that we were good with that. They are graded, but I can't give them back yet. So just, if you want to see it, I'm happy to show it to you later, though. All right, so same thing still applies. These are or equal to's. So these are both going to be brackets. So y less than or equal to -3. So I have a bracket at -3 going outward. And then or y is greater than or equal to 3. I have a bracket at 3 going to the right. So this is an or problem, so they're going opposite. Six, the absolute value of p is less than 1.3. All right, so this is a less than, so this is a land problem. So that means it's and. So what happens is, since this is positive over here, when I rewrite this, I write -1.3. So whatever the number is, I write it as a negative. Keep the symbol the same way. So less than p, less than, and we copy it down 1.3. Okay, so basically it gets copied down exactly, and then we have whatever the number was with a negative in front, and the signs are facing the same direction. Okay, so notice these are both less thans here. That means that p is between those two values. So with my graph, and again, your scaling is not that critical, however you want to scale them. So I'm just counting by ones, so I'm just going to approximate between here. These are parentheses because they're just less than. So we're in here. And it's shaded between. All right. moving into some that actually have some math stuff happening to them. Yes.
Oh, why do they call it land?
Less than and.
Oh, alright.
So 10, the absolute value of b minus 5 is less than 10. All right, so again, this is a less than, so it's land. So it's an and problem. So we take the number that's here, we put a negative sign on it and stick it out front. So negative 10 is less than, the middle stuff here, b minus 5, is less than 10. Now, just like when we were solving these before, I want to get b by itself, so I add 5 everywhere. So that's going to give me negative 5 is less than b, less than 15.
Divide by
Hmm?
-5. Add 5.
Add 5.
I added 5.
Oh, you did big graph.
Huh?
Good graph. I don't think you have to do anything else.
I know, I am going to graph.
I'm confused.
She's saying,
Oh.
Brain thought we had to divide by 5.
Oh,
She's
yeah,
saying
divide.
that she subtracted 5. That's how she got her answer. That's what she
No, I added 5.
That's what I meant. Add
So now I will graph
5.
this.
Shut up.
Not right.
Nobody knows. All right, I'm going to count by 5s.
No, you don't.
Say we don't know.
Well, that was
Why are you bullying me? I helped you. I'm not bullying you.
All right, so this one is between, they're just less than, so it's parentheses. So parentheses on negative 5 and on 15 facing inward, and I shade between. All right, 12. The absolute value of 2, they use s, but I'm going to use x, so it's not confusing. 2x minus 7 is less than 1. So which situation is this?
Land.
Land. So how would I write it?
-1 is less than 2x minus 7 is less than 1.
Yep. So we put the number with a negative sign, then we do the less than, stuff in the middle, and then the stuff on the right. So now to solve this, what do I do first?
Yeah, plus add 7.
Add 7, so that gives me 6 less than 2x less than 8. Now what?
Divide by 2.
So I get 3 less than x less than 4. And I can graph it. I don't know why I just put a 0 on there like that. Parentheses or brackets?
Parentheses.
Parentheses 3 and at 4, graphed inward. All right, this next one I'm gonna have you do on your own on your paper. Then we'll go over it because this is another one like what we've been doing. 9 minus 4n, or sorry, that's the absolute value of 9 minus 4n is less than or equal to 5. So take a minute and do that one. Make sure you remember your general rules of doing inequalities when you do this problem. All right, what situation did we have on this one?
Land.
All right, so how do we set it up?
Negative 5 is less than or equal to 9 minus 4 and is less than or equal to 5.
Okay, and what was our final answer?
14 over 4 is greater than or equal to m, which is greater than or equal to 1.
I did it. I reduced it down from the 14 over 4.
Or you can flip it and make it in numerical order.
I mean,
Yep.
do you have to?
Yes.
Okay, then.
All right, so yes. So yes, 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 and yes. Okay, so setup was good. We subtracted by 9 everywhere. Then we divided by negative 4. When we do that, we've got to flip those inequalities. So they went from being less thans to being greater thans. Okay, so then 14 over 4 needs to reduce to 7 over 2, which you could have done that right away when you did 14 divided by 4. I just wrote it out step by step so we could see it. So we had 7 over 2 is greater than or equal to n is greater than or equal to 1. But as was pointed out, that's not in numerical order, so I need to flip it. So 1 less than or equal to n less than or equal to 7 over 2. And then I graphed it there at 1 and at 3.5, and I colored it in the middle. Any questions on that one? Leave it there for a second, make sure everybody has it.
Wait, why do you have to flip the sign?
So we divided by a negative. So anytime we multiply or divide by a negative, we have to flip it. Seems like for some reason most of the even ones are and most of the odd ones are or. I don't really understand, but we're going to have an or one in a second. All right, next problem, 16. The absolute value of 4 over 3, I'm changing the variable, x minus 7, close off that absolute value, minus 8 is greater than 3. So first thing I do before I determine if this is an and or an or problem is I've got to get that absolute value by itself. Okay, so what do I do first? Add 8, and so that's going to give me the absolute value of 4 over 3x minus 7 is greater than 11. Now, what situation is this one? Gore, because it's greater than, so it's an or problem. So to get it in numerical order, or what should put it in numerical order, we actually need to do the negative one first. So I'm going to copy it down exactly over here on the right, and then we'll do the flipped one. I always like to do it as is first. So 4 over 3x minus 7 is greater than 11. I'm going to put or here. So then the other one, we flip the inequality and we change the sign of this number. So 4 over 3x minus 7 is less than negative 11. And then we just work these down, 2 separate problems. So add 7 over here. So 4 over 3, x is less than negative 4. Now I multiply by 3 over 4. So everything on the left cancels. I have x is less than, and then the 4's cancel over here, so negative 3. So x is less than negative 3, or I'm going to add the 7 over here. 4 over 3x is greater than 18. I'm going to multiply by 3 over 4. So x is greater than, let's see, 4 and 18 reduced to 2 and 9. So what is that, 27 over 2? Or for the purpose of thinking about it, x is greater than 13 and 1/2, if you need to think about it like that for the purpose of graphing. All right, so this is an OR, so it's graphed opposite. I just went way too far out with that. Let me just start over. Looking at the 27 and not the 13. Okay. So I counted by threes. Again, you can count by whatever you want. So I've got, it's an OR, parentheses, facing opposite. Something like that. Let's see, 18. 2 times the absolute value of 3w plus 8, and then minus 13 on the outside is less than -5. So what do I need to do first?
Land and also averaging.
Okay, I can't determine land or GOR until I'm done because it could change by the time I move all this stuff around. So add 13 first. So 2 times the absolute value of 3w plus 8 is less than 8. Now what?
And divide by 2.
So then I have the absolute value of 3w plus 8 is less than 4. Now we can say, is this and or?
Now it's land.
Land. And I say that because sometimes if we had a -2 out here, it may cause the inequality to flip. So that's why we want to wait till we have it completely by itself to determine which way we're doing it. So how do I set it up?
Then a -4 is less than 3w plus 8 is less than -4.
+4.
Oh yeah.
All right, so subtract 8. I've got -12, less than 3w, less than -4. Divide by 3, -4, less than w, less than -4 over 3. So this one's going to be graphed between. So I've got parentheses at -4 and at -1 1/3 and graphed inward. All right, last one. I'm going to have you do it by yourself first, and then we'll go over it. 2 over 7 times the absolute value of 4f plus 6, and then outside the absolute value minus 2 is greater than or equal to 10. Take a couple minutes and do that one. All right, what did we get?
F is less than or greater to -12, or F is greater than or equal to 9.
Everybody agree?
I did it.
You did it.
I
You
did
said
it.
if F is less than negative, you're going to tell me equal to -12.
Wait, what?
You said less than or greater than -12?
Oh, wait, what did I do?
No, you have the right answer. You just said F is less than or greater than -12. You meant or equal to.
Oh, yeah. Same thing.
All right, so first thing we did was add the 2 over, then multiplied by 7 over 2 to give us the absolute value of 4F plus 6 is greater than or equal to 42, which at that point told us that it was an OR problem because it's greater than, so GOR. So then we split it, copy down exactly over here. On this side, we flip the inequality, change the sign on the number, and then just solve it out, subtracting 6 divided by 4. And so we got F is less than or equal to -12, or F is greater than or equal to 9. And then there's your graph there for it. Any questions on that?
9.
All right, problems then are 3 through 19 odd.
Like,
Wait a minute, that's like.
And
Oh, damn.
23. That's it.
oh, guys, it's more than 7 problems. That's what we do.
Oh, snap.
More than 7 problems.
My biggest fear.
I had a teacher that used to give us like 50 problems a night, so.
Oh,
I like
thank
this one
you.
more.
I like this teacher, guys.
Shut.
Wait, if we had your